save.
Hey, I'll give you 150 people. That changes every 3 months. Right. I've got 7 classes.
Holy crap.
Yeah.
So yeah, never mind. You would have a hard time.
It is what it is. I've never been good at like doing that. I don't know if they ever tell you like make some facial feature or something that you turn into part of people's names. It doesn't work. I just have to use them.
That's me.
And in places like this, unfortunately, I end up with this problem that in your seats and reading the name, I get it. But sometimes if I go to talk, I'll be like, out in my head, I'm picturing your seats and I have to go through the list of names to get the names
Like
back.
if you run into one of us in the middle of nowhere, like randomly out of class.
Yep, and sometimes it's worse in different classes because I've got some same names in different places. And so it is what it is.
Yeah, mine's probably pretty rare.
No, well, I've had many Austins, just not many this semester.
Yeah, there are a lot more like kids my generation. There was a lot of them, like growing up in like the mid 2000s.
We okay? Wasn't sure if something fell from the ceiling or someone slipped. I'm not trying to draw attention. Sorry. All right, let me go here.
I was born in '96. There's quite a few of like for my age range that I know.
So I want you guys to have the midterm. I said it was going to be on chapter 4, up to chapter 4, and I was going to give you programs to read. I'm going to aim for that. I said you do it after we came back. So what I think I want to do for you guys is, if I remember correctly, I said I would post it this coming Friday. If I said I would post it at the end of this week. It's kind of one of the last conversations we had. Didn't want to give you tons of things to do over the break because a lot of you guys are working on your programs. What I will do is I will post the midterm idea on the weekend, and then when we come back next Tuesday, we will take the in-class portion of it. And what it will be is the thing that most people want to see from you is to read code. So I'm going to give you about 3 snippets of code, and you tell me what it does. Okay. If you go through the book, if you've been following along in the book, they do that a lot when they say they trace the programs, or you look at the slides and they say tracing the programs. That's the idea we're looking at from here, is that you can have an idea of what's in the memory or what will be displayed as the program progresses. And you'll see today, because we're doing loops, I think I'll try to use, because I don't use the animations on the slides, the traces look weird here, but we'll try to work our way through some of the traces. We okay with that?
Yeah.
All right, so I am going to start talking about chapter 5 and 6 this week. We will extend these 2 concepts out. Loops themselves aren't that bad, but loops without methods are almost completely useless. In fact, methods will be kind of one of the key components we will use in the future. So to give you an idea of, so this Friday I'm releasing what will be the midterm, and we will do it next Tuesday when you come in. It will be just like in the book, when it says kind of trace code. I'll give you some code and you tell me what it does.
Yep.
Okay. Which I think I warned you about before we left, and I said I wouldn't discuss it until we got back.
What do you mean release it Friday?
I'm going to give you an example. Basically, so you know what it looks like. I don't like anyone ever sitting in and not knowing what they're going to get. So I always give an example of everything coming across. Let's see here. I want to talk about chapter 5 first, and loops, and this will probably take most of today. If I can actually get into my loops here.
Blackboard.
Let's see here. I'm not sure if I put the slide up yet or not. I'll make sure it's there.
Yeah, I'll look because I want to follow along.
No, let me see here. Let's see if I can fix that while we're here then.
It'd be under course content, right? Chapter 4.
No, they are there. It would be under lecture notes for chapter 5.
Yeah.
And so they are there.
Yeah, it's there.
All right, so let me make this smaller. We cursorily looked at a for loop. We've used a for loop as a construction, and we're going to explore the different types of loops we can do. Loops allow code to be operate in repetition. And so if you want to repeat a string 100 times, you would need, if you go back to the table of powers that we did, right? We did these table of powers, and in each line, it'd be really, really nice if the program just kind of, hey, my A value is 1 larger than it was before. Hey, my power value is 1 larger than it was before. And have the program build it line by line by line. And so to do that, the program needs some way to repeat. And so we call that a loop because in structure, we have a decision, just like we had with an if statement. And if the decision is your exit condition, you go to the end of the program. But if it's your continue, you do stuff. Do stuff, yay. Do more stuff. Right. I'm not making a great flow chart here, but
Yeah, that's the idea across.
and then you come back and you repeat the decision. And so there's a way for the program to come back to itself. Now, for us, this is going to be contained within brackets. I think I'm going to actually start with an example of a for loop, and we're just going to make the for loop work. And we're going to do it with the table of powers that we did before. So I think I have enough visibility here that we wanted to do, we had a squared, a cubed, a to the fourth, a to the fifth, right? Did I make you guys do it all the way up to the fifth?
Yeah.
That was neat. I'm sorry. And let's say we want to do it from, we want a to go from 20. Well, we'll start with 1 to 10. Right? So. Now, if I were going to do this as lowly old me, I think if I'm going through and calculating what I need for each value, well, how would you process this? Would you now come and do 1, 4, 9, 16, 25, 36, or would you do 1, 1, 1? What would you do? Did you do it by rows or by columns? Like if I sat you down by hand and said, hey, fill the rest of this table in, I think I'd do this. Yeah. Right? I think that's an easier calculation, right? So maybe that's what I want to do. I want the computer to do it by rows. So I have to come down and do 1 row at a time. So let's look at that making it. We'll make a small flow chart for it, and then we'll come in and code it. So
Yeah, that makes sense. Because
if I want to start my program, I guess I'll print a header. Right, because this thing here, the values don't really change. It's a header. Then I want to come through here, and I guess I'm going to do something with my values of A. So I guess before here, I'll make A equals 1. Right? And so I'll go A equals 1, and then maybe I'll try to make A equal 2, A equal 3, I'll work my way down. So I'll let A equals 1, and what did I say I wanted to end at 10? So I guess my decision is A bigger than 10? If it's yes, I will end.
And if no,
If no, well now I have to print a line. Well, for my line, it looks like I'm repeating, right? I'm doing A to the first power, A to the second power, A to the third power. So can I loop inside of that? Would that make sense? Kind of loop through the columns? Let's look at it this way. Let's set the power equal to 1. What did I go up to? 5?
Yeah.
So if my power is greater than 5, then I want to go off this way. Well, I guess I have to make A bigger, right? Because I finished a row. I'll come back up here. If it's not, print A to the power, make my power +1, and now I come back here. So I gotta have 2 loops going on. One that works all the way up to 10, but that won't work until my power is, what I said, greater than 5. Okay, so yes, greater than 5. Notice there's some features with loops, right? I have to have some decision to keep track of things. And I have to come back to that decision. So in the big loop here, I have to make sure that my A increases, or I'm never going to get out of it. In my little loop here, I have to make sure power increases, or I'm never getting out of the little loop. So I need some gateway boundary, which in this case, here is the largest value. And here is the largest power.
which would be 10.
Well, we'll play with it in a couple different ways. All right. Get into your applications, and if you want to make a new package for Chapter 5, that's good. If you're still using the same place, we'll use the same place. I have a whole Chapter 5 space here, so I'm going to... Oh,
Yeah, worth a shot.
no, my Eclipse updated
Oh.
while we were waiting. I noticed it sent me out for an update, but let's see if
Okay.
it's still visible here. Hey, that worked. Alright, so let me go back into here. Let me close that. Alright, so we're just going to make a new class inside of... Now again, I made a Chapter 6. I have things by chapter so I can find things. But if you're comfortable with it, your in-class folder, right? So just be aware of that for our package naming. And so I'm going to do a new class. And I'm going to call this my table of improved powers. And I'll make sure there's a public static void on it. I'm going to turn off this front light because I'm finding that's annoying.
My Eclipse is still turning on. There we go. New class.
Let's see here. I guess the first thing I want to do is I want to print my header. And I'm going to do this in a way that hopefully will help me as I work my way through. So on the system, I think I will add comments here in case anyone needs to see them at some point. Okay, so let's see. Print the table header. I'm going to use printfs, I think. Because I'm going to want this formatted. And I think I'm going to repeat my format here. All right, and we kind of ended with printfs at the end of chapter 4. So let's start using an example of a printf. What?
Oh, nothing, I'm thinking out loud.
Yeah, I did chapter 6. I should have said chapter 5, but such is life.
Yeah.
I picked the wrong thing. So what I want to do is I want to hold places for these different elements. So I want a string. Well, how many spaces does the string need? Well, it needs 3, right? So there's 3 spaces in here. I think my digits for my number, when I get 10 to the 5th, it's going to hold, what is 10 to the 5th? It's 100,000. And 10 to the 4th is, right, 10 to the 3rd is 1,000, 10 to the 4th is 10,000. So 10 to the 5th is 100,000. So that's 6 digits, right? So I think if I have space for 6 things, I'll have enough room to keep everything. Does that make sense? So I want to kind of use my string formats to do that.
Otherwise, point of sale system.
Add jump scare.
Well, worst things could happen.
Yeah.
So, let's see if I'll open it up here. If we go back to the end of strings and we look down at the string formats, I can specify a character. Or I can specify a string. And I think that's what I'm going to do here is I'm going to specify a string in my printf for right now. So I'm going to have a percent string, and then I'm going to put a space after it, and
Percent string.
oh, how do you like your tables to look? Do you want lines between things, or do you just want a lot of space? Lines. All right. So let's put a pipe.
Pipe. How do I do that one?
Above enter, above the backslash. That's a weird slash.
Enter backslash.
No, it's above enter. The key above enter is the pipe.
I never knew you could do that. Okay.
So let's see. That's a squared, a cubed. Right now I know I'm going to have to change some of this stuff as time goes on. So a squared, a cubed, a to the 4th, a to the 5th. And I'll use pipes to frame all my characters. Now with formats, this is holding the space for things. So I need to say what's going to go into each of these spaces as time goes on. We okay with that idea?
Yeah, hold on, I'm still right here.
So this is the first string will be a. The second string will be a squared. The third string will be a cubed. And the 4th string is a to the 4th. I might separate this out onto 2 lines so it's visible. Give me a second here. I'm just going to, I put a return here after the comma, and I'm going to explain this line. We introduced string formats in the last class. This is the string it's going to print out, but it's holding place for a variable to go in here. I can give it a variable, but it wants a string. So here are my 1, 2, 3, 4, 6 places it's holding. It's going to put into those places 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Yeah, I counted wrong. Sorry. Okay. I have 5 places. I have 5 things to go in these places. Right now, we're not getting anything great from this, but watch what we can get out of it.
Wait a second.
I'm going to give you here, formats don't do a new line, so I'm going to need to tell this to do a new line when it's done. What?
Up to 8 to the 5th, right?
Yep.
Okay.
I'm really tempted to run this
What did I
because
do
I like
wrong?
running things as I go to make sure I didn't make any weird typos.
What did I do wrong here?
What's it doing?
It just has an X mark. I think I might have copied it incorrectly. Oh, I see what I did wrong.
So I've got an odd thing going on here. Notice how these are all the same size. Because all of these strings are the same size except the first one. So I want to cheat. I'm going to put a space on either side of that. Right, because these all have 3 characters. So I want to give that 3 characters. I think we'll play with it a little more as time goes on. But I now have the beginning of something I can control the spacing. Does that make sense? Hopefully we'll see.
Which button is return on the keyboard?
The enter key and return are the same key. In general parlance, I mean, for modern computers, yeah.
Yeah.
All right, so that's let's loop through values of A. So I'm going to use a for loop. So I'm going to introduce my value of A. It's going to start with 1. Now, 4 will contain this entire looping structure. I'm setting A to equal 1. The next thing I need to do in my for loop is I need to check if A is greater than 10. And I can do this by A greater than 10. So the way for loops get constructed is I generate a variable. Now I'm going to call this variable here. I'm going to give its value here. I'm going to do some comparison that I need to do to exit the loop. When A is greater than 10, it's going to stop looping. And then I need to tell it, whenever it gets to the end, that it should increase A. So this loop here goes through, and it starts with 1, and it works its way up to 10. Well,
What did I do wrong here?
what's it say?
I just think I typed it wrong. Multiple markers at this line. Syntax error on token plus plus.
On token plus plus. Do you have a semicolon before it?
Yeah, semicolon, then a space.
Let me
Get rid
finish.
of the space. It didn't work.
Oh, your error's up above. You have an error here. So whatever's happening there, multiple markers at this line. Move your mouse. Since you don't now print, you closed your double quotes too early. So it's reading everything as double quotes. And now that gets you on the second line.
Oh, it's because that's when I clicked enter.
You
it did
don't
that.
need the plus line.
Yeah, I clicked enter, it did that.
And now I'm going to 4 int all equals 1, a greater than 10 plus 4. Should be A plus plus.
Oh.
All right, so
Okay.
D, again, I'm going to go back to the thing we have for percent D lets an integer go into place. So I'm holding a space for an integer. So let's see. And so the integer I'm going to put into that will be A. And again, just I'm going to put a slash n so it creates new lines. System.printfs don't create new lines by default. And so I need to tell it to do a new line for right now. I just want to see what this does, right? I know I don't have my powers in there yet, but let's try this.
Line 14. System.
Print D.
You're thinking you're gonna make it say system.out.println.
So I'm going through my loop. Am I still running? Did I mess up my loop? Let's run it again. No, so I am not getting any output here. What did I do wrong? A back into D. Let's try an F. See if I get a floating point error. Nope. Huh, now I made a typo. So let me just, out of an abundance of checking to see what I did wrong, see if my loop structure's off. Yeah. So my A is not being seen in my loop. A equals 1, A greater than 0, print line. This is the exact same setup I have over here. Give me 2 seconds here. System.out.println. Is everyone getting a blank screen when they go to print line? Yeah.
Should it be A is less than 10?
Yep. No, this is the exit condition. So, well, oh, yep, you're right, less than. My exit condition less than and equal to 10, less than equal. Thank you.
Oh, I see what you're drawing.
All right, so all right. Yeah.
There we go.
Let me change this back to printfs. D/n, comma A, make sure my printfs are alive.
DNA.
All right, so I'm able to have my printfs contain the A. Well, now I need to work my way. I know I can do a row, and I'm printing each row. So inside this row, I want to loop through my powers. And see if I can do my for loops again properly. Thank you, Sansi. So I'm going to call my power. We start with 1, and power is going to go to less than or equal to 5. And we're going to increase power by 1. I want my output to look like this. I want these things to work their way down, all the way down. So I'm going to cheat. I want to copy this. So this is guaranteeing that the placeholders will be exactly the same as the placeholders here. For now.
Power is greater than 4 equals to 5.
Well, less than or equal to, that was the thing I flipped on the previous one while it wasn't working.
Yeah.
But I actually want the values of the answer. So I'm not going to use strings. I'm going to change these to integers. Now remember the character we had for integers was D?
Oh, I see what I did wrong. I put that in the wrong place. No, I didn't.
Now I need to pass out of this function an integer. So the first one is a to the first, right? That's what we get for the first one. The second one, well, I'm not sure this will work. It's gonna have to do these one by one, isn't it? Well, notice printf needs a new line. What if I didn't give it a new line? What if I just told printf to print the pipes and an integer? What integer does it want? Well, we want math.power. I can type today. Our base was A, and our power was power.
%D.
And what did I type wrong with power here? Integer. Yep. Sometime in the course of my life, I will have a semester where I'm only dealing with one computer language. Right?
And who knows if technology works going, probably.
So let's think about what this will do. So I come through, A is 1. I come down here and I set power equals 1. And I print A to the first power. Then I get to the bottom here and I increase the power by 1. And I print A
Oh, I see what you're doing.
to the second power. And so this will loop through and do this. What do you think it's not going to do when it finishes a row? What is it missing? Well, it's new line. I've got to wait until I've printed everything in a row to print a new line.
No.
So I'll print a new line here.
Let me look. Trying to see what I did wrong here.
All right, let's run this and see if it gets close.
Wow, allergies, I guess.
We're close. It's not lined up right. Right? Notice how it's doing 1 digit for these, 2 digits for these. So the table doesn't line up. But look how much more quickly it got a table format, and it had some spacing characters for us. I'm getting doubles here. What do I have to fix to get rid of the double? This is what it's printing. Why is it doubling?
You have that first line or the second one?
Yeah, get rid of 1. And maybe that to end. Oh no, I'd have to do it each line. Yeah. We'll have to play with our format.
I did it with just the one at the end.
Just the one at the end?
Yep.
But you lost your first one, right?
Damn it.
Oh, there's no first one.
Oh,
Right, so we can print those up here. Do you see how we're dealing with printing? But for right now, let's come here. And I'll show you what I mean. And user interfaces are always I don't want print line. I want a regular print, I think. See if that
In
works.
between the two forums.
To the, yes, between the two fours.
Okay. System out print.
So I have to print the start of the line before I start working through the powers. And I have to print the end of the line when I'm done working through the powers. Still a lot less typing than what we did in the first one, right? So now the only thing I have to worry about is my spacing. What did we say this largest one was? It was 6 characters? So let's come up here and fix these strings, right? I made all of these, 3 characters? Some short 3 characters, right? So let's put 1, 2, 3, 1, 2, 3, 1, 2, 3, 2.
So 2 spaces in between.
Nope, 2 in the front, 2 in the back. I'm adding 3 spaces to everything.
That's what I mean.
We're going to find ways to have the computer do any repetition for us here. But right now, I'm just trying to get this to look consistent.
Yeah.
So if I look out at the end here, I've got wider spacing now on that first line. It'd be nice if I could force this to have a set amount of characters.
60.
I can tell a format how many characters to always print the number in. Can tell how many decimal places I want for a floating point, which will work really well with money for us. So by specifying 6D, this means that it's holding space, 6 spaces for each integer. Look what it did for my table then. Because I'm holding 6 spaces for each integer, it's leaving padding here. And my table lined right up. And so we can minimize the amount of code that we use. All right. So our format statements let us specify how many characters it will reserve for that space. It will always use 6 characters now. This is how, like, when old spreadsheets used to get printed, or the computer ream paper, or it would print checks. We'd make sure everything was in the right column. Well, we're going to have to do that with money at some point, right? Because we want our cents to line up with our dollars if we print a point of sale receipt. So these string formats now guarantee I have a nice consistent table. The looping lets us keep using the same code over and over again. We okay with these concepts?
Yeah, what am I doing wrong here? You just double check with me.
What does it say?
A couple different places.
You've deleted your ending braces, so your class doesn't line up at the end. So your public void static main doesn't have an ending, and looks like you lost you lost your for loops brace. You lost your
Four there.
the for loop. Four. That should have a brace to end it. So you have 4 open braces and 2 closed braces.
Open brace.
So it looks like you deleted from the end your braces.
Add a closed brace.
No, not there. Right. So if we look at the containment of our braces, which is what, so the class itself closes all the way down at the bottom.
Yeah.
The public
There's no
void closes at the one above it. And then in the for loops, you see how they're highlighting the opening and closings? When I click on this one, it shows me where its closer is. Can you see that highlighted, Austin? If I highlight this one,
Yeah.
it shows the closing one. If I highlight this one, it shows the closing one. So the four loops have this for loop has a closer here. This for loop has a closer here, and you lost these two trailing
Oh, now I
braces.
see it, yeah.
Yeah, you lost the two trailing braces. And that does kind of bring me up. Is for loops are only do what's in the braces, and this variable, if I declare it here, doesn't exist outside of the braces. So if I come down below here and try to use A or power, they're out of scope. To protect its memory, wherever you declare a variable, that's as large as Java is allowed to see it. So by declaring this integer A here, it's only good in between these braces.
So
By
where
declaring
would
this
I-
integer power here, it's only good between these braces.
Yeah, so where would I put the bracket to close it?
So you deleted the last two brackets. So below 19 on mine, 20 and 22 were deleted.
19 and 20.
Below 19, 20 and 22 you deleted.
Ah, okay.
All right, so what I want you to do with this is I want you to modify it. What I want you to play with is your string format. And so right now, I put in 6 places to hold the character, and that was enough to, sorry, I'm trying to lift my bottom here, and there we go. There we go. That was enough to line everything up, holding the 6 character places, right? So modify this and modify it so it lines up the columns appropriately. If instead of going from 1 to 10, you go from 11 to 20, right? The next grouping. And instead of going from A to A to the 5th, go to A to the 6th. So increase it by 1 column and look at larger numbers. That's going to change the width. So you will need to edit your format statement. That make sense?
Yes.
Anyone need anything?
You kind of lost me because I was busy trying to fix my mistake.
What's up? I have a space before that. No, the difference is the percent, 1% and one after. Other stuff. You still do what? Drag. So let's see, we have 6 spaces in there. I know what I did. When I came through, and let's see, so percent 60. So let's look at this here. So you have your spacing on your D. So I have space percent 6D space pipe. And on each of these up here, it's not one. First one's line up. Okay, it's adding the 6 spaces. Just try it. Okay. I'm just using the standard built-in. Is anyone else getting them not lining up? Yeah. Okay, so you might be a font setting. You're right on that. I'm gonna look at mine, see if there's a difference here. I think it's the font being used by the console. This is so if I go to preferences here, my console settings, use window maps. I've got let's see. So I don't have fixed width. I have a buffer size of 80,000. My tab width is 8. Is your enable word wrap, show background color same? Yeah, I'm noticing mine look like mono fonts, mono-spaced fonts, and some of yours don't. Let me see. Prompt editor, activate workbench, change color. I'm going to go here to welcome to computers and the problem with user environments, right? If we were programming the windowing system, we would enforce, right, monospace fonts and character lining. Since we're working on a command line, generally command lines use a monospace font. Like if you were running this from your DOS window, it would line up. I'm wondering if it's here in the text, workspace, working set, references. Let's see here, refactor, source. Trying to get to, what did you do?
I didn't change my font a couple weeks back, and I just converted it in that time.
So it was a font change. Where was that font change?
The top right is the little thing, that's right. Preferences somewhere. I changed it
Top right. So anyone else that has this, I'm trying to get the same thing. What is your font currently?
I don't know what it was, but I reset it to like the default.
And
Just restore defaults.
where did you said up on the right? Is it the right of the console or
Right of the entire screen.
up here?
Yeah. All the way up with that little bar. It's the search icon that I just search text font.
Okay, so you did. Oh, so you did here text font. Okay.
Why would you need to change the font?
Well, he changed the font and it wasn't monospaced, so nothing's lining up because we're using the space on things from here.
Oh.
So, and colors and fonts general. So you came in here, and what did you do? Use you just went to reset.
Yeah, just restore defaults.
All right. If you're having the problem with spacing, try that. That should make your console monospaced.
Text font.
All right, so what you want to do is you want A to go from 11 to 20, and you want power to go to 1 to 6, and then you want to play with your spacing. You want to be able to play. I'm going to go back here and then work my way forward because more questions were before.
So you want me to decrease it or increase it?
Everything's increasing.
What's up?
So mine's everywhere up except for the very last one, right? All right, working my way forward. Was it JM next? JM more closer. Yeah, playing with space.
I tried to do the font thing, but it didn't give me an option to reset.
And you're there. Okay. All right. Good. Yep. And you figure out how much wider they were, right? Because did you have to change? Yes, you had to go up to 18. Is the number up here. There you go. But now, think of where we were before. Now you can work on making your output consistent, right? You get come across. So we have a little more flexibility, and we're letting the computer do the cut and paste for us. Okay, anyone else have questions? I'm working my way forward. Thank you, Captain. Sorry.
Is this what you wanted? 8-6 and to 11-20?
11 to 20. You're going from 1 to 20.
Oh, so I got Grace the first 10.
So how do you think you might want to do that?
Change this.
Yep. There you go. So, two things, right? I brought in the format statements that we ended last time on, right? And how we can use those to flexibly throw variables into a spacing. And one of the things that we're going to have to do with format is we're going to have to learn these little codifiers to put in here, right? We'll work with money next class, okay? So that we can tell how many decimal places to have, right? So we want to do money, we always want it to have 2 decimal places in the output. And that'll line things up. One of the things you'll have to do is make a point of sale. Right? You ever go to a restaurant, you get your receipt, and all your dollars and cents line up under each other, right? So we now have this flexibility that we can put any data we have into a space that we set aside for it. And we can repeat ourselves, which now the computer's ability to run quicker is going to help us solve things. Your repetition. We'll have to watch things like you don't flip the greater than or less than sign like I did to start with, because I had a massive brain fart. But these happen, right? You run things, you change some things, and you try them. All right. 15 minutes.
Was it 15? I thought it was 5:20 in the class was over.
Yeah. How many people are still working on this to get it changed? You happy with your output? All right, well, then we'll look at a different type of loop. Moving across. So for loops, I think work really well for indices, things that are countable. They move their way across. Yes?
What's like the major difference between a for and like a while loop?
So while loops, so this for loop has this construction where I initialize some value, I look at the exit condition for the value, and I increase the value. It has these 3 parts.
So it's just the main difference is you set the conditions in before like the beginning of it.
Well, and how it then constructs the loop. It initializes this before it enters the loop. It checks for this before it enters the loop. And then when it gets ready to finish the code, that's the last thing it does. So it builds it inside the machine code.
So it's just a shorter loop than the while loop. Because you could do that with the while loop if you just added it all in there, right? Inside of
Yeah,
it.
And that's kind of what it's adding up is, do I have enough time to change this to a while loop? We can change these to while loops and see the difference. And so I'm going to do a while loop, and then there's a do while loop. We'll probably won't do while loops today. And those are the 3 really big looping structures. We're going to look at the while loop, and we're going to change this to a while loop. And some of the things that we can do with while loops. So let me come here. Here. All right, so a while loop, I have to initialize the variable outside of the structure. Okay? In the for loop, that was done for us inside the structure. Then I have to check before I enter the loop what my exit condition is. Then I come through here, I have to make sure that I update the thing I'm checking. So the for loop does it all in one place, in one line, and it marks us. It will construct it like this, right? In the loop that we did for A, it actually sets in memory, it set A equal to 1 right before it enters the loop. It then enters the loop, the first thing it does is it checks this. And then it comes through, and then the last thing it did was it did its update. So for constructs that automatically. The compiler takes care of it for us. Here we do it specifically. The reason for this is, well, for loops work really, really great if I'm counting things. 1, 2, 3, 4, counting by twos. They were really designed for working their way through indices. While loops, I can have any comparison I want here. I can have this look to see if a certain key was pressed. Right? It doesn't have to be numeric. I don't have to update here. I can have it, right, do a scanner option, see if the user has typed in the word exit yet. If not, run the program. So I could constantly be going, has the user typed in exit, has the user typed in exit. I don't have to update. Is that,
Yeah.
well, and so technically, yes, we can do the exact same thing with while loop, but the while loop has a little more flexibility. It also means with while loops, I can very easily not have this condition ever met. For loops, now in Java, notice I put my comparison around the wrong way. And in Java, by putting my comparison around the wrong way, that for loop went on forever. Some languages won't let you do that. They'll actually check to make sure that the for loop terminates. So, small difference. The actual compiling code structure is the same. What gets compiled and run. How you interact with it is different. All right, so if we look at a while loop, and I'm going to use their flowcharts because my handwriting in the darkness in here is getting odd. Is this visible-ish between the two screens? So with a while loop, and using this count example, it creates that initializer, checks it. If it's false, it goes to the end. If it's true, it comes back right in the spot in memory after it initialized. So it doesn't keep reinitializing. I would love to have a course in assembly where you write machine code and to see what the compiler is doing here. Because this idea of pointing back to here, in machine code, you have to point it to a place within your program. You have to build a pointer to point it back to. And that's one of the things you can get wrong is you can point it back to this. Sorry, it's just what I'm thinking. What I'm saying, it's pointing back to a place in your code. You can kind of think of your code living in memory. And this says, hey, I've got to come here right after in memory that command was executed. So while loops, check the condition, run what's in the loop. Go back, check the condition. So notice it checks the condition before the loop starts. You can have a while loop never run because the condition to run comes out false. So I'll skip the trace here. Sorry, I hate. Yeah. Another thing while loops can do is this term. Sorry, they had two example programs in here. Is a sentinel value. You can have a watcher value go. A very common while loop, you're running in one inside a main. Main waits for the program to send an exit command through to it before it exits. But let's say I want the user to play a game, right? So we'll play a guessing game or an addition game. We'll have some game going. And so I can have a sentinel value which I can set to true. And my while loop will say, hey, while the sentinel, right, while this thing is true, do stuff. One of the last things I can ask is, do you want to quit? And if the user says yes, right, the user types in yes, and then I make sentinel false. Right? So I set sentinel to false. I come up here, and it exits from bool. I come back up to here, and it'll exit. So it's true. So you can have a Boolean value that says keep running. I think, did I use go in the example I did when we did the while loop before? And so I can have this thing that watches the loop, and I can say, hey, you're true, you're running. That means I can have multiple things turn off the loop too, right? If I have this one value that tells me if the loop's going or not, I can have different conditions check to exit. I can have, say, do you want to exit as one condition that flips the sentinel? We have another place check, hey, you've ran this 1,000 times, I'm killing you now, right? You're addicted to your screen time. Okay? So when you have a sentinel value, you can actually update that sentinel value with more than one condition, and the loop can come across. So now when I do sentinel values, I make them Boolean, so that they are a Boolean, and I set it equal to true, so that it's always going to run. And then when I want it to stop, or a condition is made for it to stop, it will then exit. So sentinel values are a very good thing that while loops are used for. In fact, I tend to use while loops for conditions that look for something updated. I want this thing to run, and I'm only going to not run if some condition is not made. Fors I tend to use for counting, because they look like counting, right? You can do both in both ways. So I'm going to end here. We're going to take our for loops, and we're just going to turn them into while loops, okay? To show that these can be done as while loops, and some things to watch. Is that all right with you guys? All right. And then we'll come back and we'll do while loops, and we'll on Thursday. All right, let me get back to here. All right, so I'm going to, for right now, I'm just going to comment out everything I have here. I don't care how you want to organize it. I want to keep this as a reference, but I'm going to do these as while loops. So you might want to start a new file. Again, however you want to do it. So I'm definitely going to do this. I'll print my header. And so if I think of my initial loop condition, what I had to do was I had to set an integer a. So I'm going to set integer a equals, and I'm going to go back to 1. Okay, I'm going to do my 1 to 10. And I wanted it to run while a is less than or equal to 10. So I am immediately going to put this at the end of my while loop, because if I do not update this, this will never exit. And notice I just wrote my for loop. I put my initializer, I put the condition I'm checking for, and then I put my update in it. So same functionality, the structure's different. And I did this immediately because I've done it before. I forget to update this, go to run it, and it doesn't run. Or it doesn't stop running. It doesn't stop running. So now I can print out what I needed. So what was the first thing I needed to do? I needed to do system.out.print. Didn't I do a pipe first? All right, if you still have your for loops here, right, you can look down, right, how you're doing these. This was inside the for loop. And now I need to do my powers, so I'm going to go integer power equals 1, and while power was less than or equal to 5. Again, I'm going to increase that right away. because of the type of thing I'm doing. The nice thing about while loops is we don't have to do this increment thing in. I could be checking something else. But because I'm imitating this for loop, I am making sure that I have the structure of the for loop there. And then I needed, what did I do? I printed my line out. So I'm just going to copy the line here. Because I don't feel like retyping that. Right? And then I did a print line. I think I recreated everything in there. Did I get everything? Am I missing something? Oh, let's run it. All right. Notice I'm trying to talk like how you should be working on your programs. Did I get everything in here? Let's run it. Let's see if it does what I wanted to do. That's sometimes when you're looking at the program, don't want your code to be perfect. Just go, hey, what happens if I do this? And sometimes you go back and forth, change it. Notice when I was first doing this, I just wanted to print out the values of A to see what was working or not. So this while structure here in this format does the exact same thing as for loops. All right, that's all I have for today. Please continue to get programs through. I'm getting programs back to people as we go through. A couple of you have had some things that haven't run. Please check your first 2 or 3 programs where some of you have sent me the class files, not the Java files. I've had a couple people send me a Java file, but it looks like compiled code. It doesn't look like a .java file. You'll see those in your Blackboard comments. Right? And if you have any questions, holler. Again, I'll drop down the example programs. If you want to be ready for what the midterm looks like on next Tuesday, just think of the trace programs in the book. We're going to write a program and you're going to have to trace what it's doing, what's in memory, what's going to be on the screen, what do you think the variables will be doing. It's very much taken from that. I would start trying to get used to chapter 5 and 6. I'm probably not going to introduce methods this week. I might have to use a method. The goal of good computer programming is 2 things. Try to minimize the amount of indentations you're doing. It's the no indentation philosophy. If you've indented more than 3 times, your code's probably getting... Now, it's Java, we have some built-in indentations, right, because of the main. But from main below, if you indent more than 3 times, it's probably good to take a chunk of code and make it a method. And a method will be a chunk of code that we'll give a name and we'll say, hey, I want to do that code again, run the method. And so a method will be a chunk of code that we can repeat, and we can keep running. Most programs tend to be methods, or if they're objects, the methods inside the objects. So you usually don't see your main doing a lot of work. You see your main calling other methods, and those methods returning values. In general, main is a container for other methods. And so now that we can loop, one of the things that we'll start doing is making methods that will do common things. You'll see, I think the first one I'm going to do is going to be user interactions. Right? If I want to do sentinel values or user interactions and I'm going to ask the user if they want to exit in more than one place, I'll put all the code that checks that into a method, and then I'll just call exit or not exit. So, read chapter 5 to get comfortable with this. I have the programs up for chapter 5. I'm going to make sure I have 6 up. I don't know if I've made it available yet or not, so I did want to talk about it first. If you have any questions on the programs you're working on, let me know. And if you want to, glance at 6, right? Because we're going to move through 5 and 6 at a nice pace. 7 and 8 are going to go fairly quick. We've already done everything we really need to understand arrays with strings. Okay. We're just going to now do a more generic set of arrays. So I suspect this week and next week we'll definitely still be in 5 and 6. Come April, we'll start 7 and 8, and we're going to end on chapter 9, right? Which is objects, which is probably the harder part of this. We're doing a lot of small programs here, right? As we move towards April, there's going to be 3 large programs that encapsulate all the chapters. They're not going to be tied to any of the chapters. And so I'm going to try to get those first, second week of April that will tie everything together. So just keep that in mind. They will be viewed, but they will be based on the fact that they'll use anything from all of the chapters to make them right. Questions, comments, and queries as I took it down. I really did babble like a blithering idiot for those last 5 minutes.
Are those the only type of questions that will be on the midterm? The ones where
It's going to be tracing, and right now I'm determining 3 or 4 problems, and they're going to either be taken from the book or taken from the example problems that the book has.
multiple choice section or
No,
anything?
it is literally just going to, I think what I might do is grab the ones from the book as the example to look at it, and probably also give you an example of an answer key on it. But it is, here's some code. What is the output of the code, and does anything change in memory? Those are the things that when you're reading other people's code, you really got to get comfortable doing. I will say that on a couple of the examples, when I've done this before, and I'll go back through the ones that I did last semester on this, I used to do find the typo or find the error type thing. I'm not going to do any of those on this go around.
All right.
But the code might not be to our style guide. It'll be runnable code. It just might not be to our style guide. Is that fair?
Yeah.
All right. Go forth. Have a life.
Have a life. Yeah, thank you. You as well.
And I'll try. I just got to stop brain farting.